Hello, my name is Marcus Casey, and this is a brief overview of Team 31, Project Looking Mass, a senior project in the course CS 426 taught by Sergio Dasculu and Devrin Lee. Our supplemental advisors are Dr. Emily Hand and Dr. Melody Rodrigue. The rest of Team 31 is comprised of Ethan Park, Nikita Ignatyuk, and Aditya Sidhir. So what exactly is Project Looking Mass? The main objective of Looking Mass is to provide open source software that can artificially generate realistic gravitational lensing and images of space. Ideally, datasets generated by Looking Mass can assist in developing faster methods for gravitational lensing detection. For example, these datasets could be used to train a convolutional neural network that can detect whether an image contains lensing. Before we go further, let's cover what gravitational lensing is. Gravitational lensing occurs when a large amount of matter, like a cluster of galaxies or a massive black hole, creates a gravitational field that distorts and magnifies the light from distant sources behind it. It can result in images of space being distorted. You may be asking, why is gravitational lensing important? Well, gravitational lensing assists researchers in discovering old galaxies that are too far away to be seen with current technology otherwise, as well as detecting and measuring massive sources of gravitation. The number of images containing gravitational lensing is relatively small compared to what is needed for applications such as machine learning. Looking Mass addresses this issue by allowing users to generate realistic, artificial datasets of gravitationally lensed images. These datasets can be used to develop faster methods for detecting gravitational lensing, as manual calculations are quite slow and cumbersome. This can lead to further findings of real images with gravitational lensing. The team also adds to aid in teaching students about gravitational lensing. We also plan on opening our source code so it is easily accessible by researchers and students, both for modification and reverse engineering. Project Looking Mass was built using the Python language, with a key focus being the open source GUI platform Kivy. OpenCV was used to implement the image processing components of the project. The team used GitHub for version control and Visual Studio Code for its live sharing capabilities. Here's what the Project Looking Mass looks like currently. While strides have been made, our application is still in development. First, users will need to upload an image they wish to apply lensing to. This can be done by clicking on the Upload Image button. Upon doing so, a file explorer will pop up representing the user's file system. Users can navigate through this explorer to select the images they wish to process. Users can select Load once they found the desired image, or Cancel if they wish to cancel the uploading process. Once an image is loaded, users can click the Show Image button to display the image within the application. Users can name the newly generated image and choose where it's saved, using the Saved Image Location button. Similar to uploading an image, when clicked, this button will open a file explorer where the user can choose the directory for outputted images. Users can choose the name of the image by entering it in the text field at the bottom of the pop-up. The metadata is a database useful for determining the constraints on the gravitational lensing tool. It currently allows the user to define the mass of the gravitational source, distant from the observer to the source, and the distance from the observer to the image. These constraints can be filled out if the information is known by the user to help the gravitational lensing be more accurate. If left blank, there will be constant variables used in order to apply gravitational lensing to the image. When hitting Save, it stores all the information into physics metadata.txt that can be used later. Users can specify where they want lensing to be generated on the image using the Lensing Coordinate Entry button. Upon clicking the button, a pop-up showing the source image will appear. Users can click on the area of the source image they wish to have lensing applied and confirm using the Apply button. After all previous steps are completed, the user can press the Process Image button to apply gravitational lensing to their source image. The lensing applied will be based on the metadata the users entered, and the new image will be named and saved based on what the user specified earlier. Here's a look at the equations used for the application. We won't go into these today in this video, but if you have any questions, please make sure to leave them in the comments section below. Thank you for learning about our project with us, and if you'd like to contact us for any reason, please do so on the email listed on the screen.